This is the second mini lecture for what we're calling section 3.2 of the lecture slides. So now we're going to talk about expected value. And let's use roulette, which we just talked about as an example. So in roulette, you can bet an amount of money of your choice on either red or black. Yeah, there's more things to do than that, but we'll keep it simple. If you bet on red and the ball lands on red, then you get double your money back. If it lands on black or green, then you lose your bet. So for example, if you bet 5 on red, sometimes you'll lose $5, sometimes you'll make $5. Okay, if the ball lands on red, then you'll get your $5 back plus an extra $5. If it lands on black or green, you just lose the $5 that you put down. So you see, it's almost 50-50 whether you make $5 or lose $5, but the odds are slightly in favor of the casino because there are 18 ways for you to make $5, but there's 20 ways for you to lose $5. So the question is, if you just keep betting $5 on red over and over again, maybe you go there with $1,000 and you just start betting your 5 on red over and over and over again. You just do that all day. What will you expect to happen to your money over time? Will you lose money? Will you make money? And about how much are you going to make or lose? What's the most likely outcome of this? So we use expected value to figure this out. If you let the outcomes of an experiment be a sequence of values v1 through vn, those are like the dollar amounts that you could win or lose. And suppose that the outcomes occur with respective probabilities p1 through pn. So v1 occurs with the probability p1, v2 with the probability p2, and so on. So here we're not necessarily assuming that the v's occur with equal likelihood. Maybe some are more likely to happen than others. So then the expected value of the experiment is v1 times p1 plus v2 times p2, and so on, plus vn times pn. So what this expected value tells you is about how much on average you expect to win or lose in the game. So the E may not even be one of the allowable outcomes. But if you keep playing the game and you don't change anything, over time, when you look back, you'll find that you made or lost about E dollars every time you played. Okay, so let's work this out for our experiment, the roulette experiment. Well, we have two values. So if we land on red, then the value is that we make $5. And the probability of making $5 is, well, there's 18 ways to get a red, and there's 38 total. Okay, black. Well, let's say not red. It's easier to lump the black and the green together. So not red. The value is that you're going to lose $5. And so it's -5. And the probability of that happening is 20 out of 38. Right, because there's the 18 red and the 18 black and the 2 green. So the expected value is $5 times 18 out of 38 plus -$5 times 20 out of 38. So let's work that out. What does that come out to? Okay, so I get approximately -0.26. That means you lose about 26 cents per play. So we can expect to lose about 26 cents per play. Yeah, but this is over time. Every time you play, you either win $5 or you lose $5. 26 cents is not even a possible outcome. But if you were to play, 1,000 times, say, if we were to play, say, 1,000 times, we would expect to lose, well, 1,000 times that. So about $263. And I'm multiplying the exact amount by that. So let me just say about $260. To be exact, to be 263.16. But we can just round it at that. 1,000 times the 26 cents. Okay, so this tells you a couple things. One, the casino does not have to be sure of always winning. It doesn't even have to be terribly likely to win. It just needs a little bit of an edge. And that edge is what allows it to make a profit in the long run. So a casino can't operate unless there's lots of people there playing the games. If it was just a few people, maybe betting a lot of money, then the casino could come up behind. But if there's limits to how much people can bet, and there's a lot of people betting, then some of those people will leave the casino with more money than they came. Some people will lose money. But at the end of the day, the casino will have made money. And I'm talking about the casino not because I think that's a great way to make money or anything. Actually it's not. But because that's the same way that insurance works. An insurance company needs a large clientele in order to operate because it needs things to average out. And when they charge you a premium, they're giving themselves a little bit of an edge so that at the end of the day, they've made a profit and they can continue to operate. But, no single person pays an inordinate amount of money. So let's look at this from a different point of view. Oh, and incidentally, before I talk about that, as far as playing the roulette wheel, another thing this tells you is that if you really want to make money playing roulette or any game of chance, you're better off putting down a lot of money at once and running the risk of losing it. So it's risky. However, if you play it safe, the way this person is doing, then you are guaranteed to have lost money at the end of the day. You might not lose a whole lot, but you're never going to make money that way. If you really want to make money gambling, you have to take big risks, and you have to do it in a controlled way. So if you were to do this with roulette, and you're just literally betting on red or something, you would just want to do it once or twice with a large amount of money, and then walk away. You have an amount that you decide, okay, this is enough for me, and you're going to walk away. And the trouble is it's difficult to do that. But doing things like playing slot machines or buying scratch tickets at the gas station, those are guaranteed to lose you money over time. When you get a scratch ticket, it may be, you have a chance of winning $10,000 or whatever. But cumulatively, you're most likely to lose money if you keep playing. Okay, and the state is guaranteed to make money because they know how many tickets they're going to be selling, and they make sure that there's only a certain number of tickets for a certain number So let's look at this from a different point of view. Let's look at it from the point of view of the casino. So let's say in a certain game of chance, the player tosses 3 coins and wins as many dollars as there are heads up. So like if you have 2 heads up and 1 tail up, you get $2. If you have 3 heads up, you get $3. How much should be charged to play the game in order to ensure that people will play, but also that a profit will be made in the long run? So first of all, let's figure out the expected value for the winnings. Okay, there's 4 possibilities here. You could have 3 heads up, 2 heads up, 1 heads up, 0 heads up. So you have 4 values. You could win $3, so we'll call that value 1. And the probability of that happening is 1 out of 8. Remember, there's 8 total outcomes here. I can list them quickly. Heads, heads, heads. Heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. And there's only one way of getting 3 heads up. Okay, so we could get 2 heads up, in which case we'd win $2. And there's 3 ways to get 2 heads up. Heads, heads, tails. Heads, tails, heads. And tails, heads, heads. So the probability of that is 3 out of 8. And then you could win $1. The probability of that happening is 3 out of 8. And you could win $0. And the probability of that happening is 1 out of 8. Okay, so the expected value is $3 times 1/8 plus $2 times 3/8 plus $1 times 3/8 plus $0 times 1/8. So let's see, we have 3 plus 6 plus 3 plus 0 divided by 8, and I get 1.5. That's $1.50. Okay, yeah, maybe we could have expected that just from symmetry, but that's fine. We use the formula, we find, yeah, it's exactly $1.50. That's the expected value. So, we could say, if we charge, let's say $1.75, then we make about 25 cents per play. Okay, so this $1.75, that's a variable amount. It doesn't necessarily have to be exactly that. If we were guaranteed that there's going to be hundreds of people playing this game, we could charge like $1.60 or $1.55 even. If it's not as many people, then we'd better charge more, like $2. So it kind of depends. The more people that you're guaranteed of playing, the less you can charge. But you should never dip below the $1.50, okay, because then you'll expect to just break even. And this is a nice example because this is the same way that insurance companies decide what to charge you. They figure out what's the expected value for you. as the consumer. And then they charge you a little bit more. Now, you might not use any of your insurance, or you might get in an accident and use many times what your premium is. But they know that on average, they'll be making a little bit of a profit. Unless there's some kind of big disaster that affects a bunch of people at once. And quite often insurance companies have a very difficult time dealing with things like that. Okay, so the homework is 14.4. I say exercises 1 through 12. That's a typo. It should be 1 through 11.